Hello everyone, I am Vibhojan from Team Green Guardians. Our problem statement is automation of drill core rock sample lithology logging. Problem statement ID 1339. In current times, our drill core samples lithology is typically determined by looking at the grain size, color, cementing material, mixing of grain of various sizes, packing, and compactness of the grains as well as their roundness. We have to automate this process. Now, our solution utilizes unmanned aerial vehicles, that is, drones, equipped with various remote sensing technologies to capture high resolution imagery and geospatial data of geological formation and drill core samples. The primary goal is to provide geologists with a wonderful tool for non invasive data collection and analysis. We have divided our solution in 6 stages. Stage 1. First, we will choose an appropriate drone and equip it with the necessary sensors for remote sensing. This may include RGB cameras, multispectral cameras, LiDAR, thermal imaging, and GPS equipment. Now, stage 2. This includes planning and conducting aerial surveys of geological formation and drill core sampling location. The drone is flown over the designated area to capture data. Now, stage 3. Now, the drone has collected various types of data during the aerial survey, including high resolution images, elevation data, thermal data, and spectral data. These data sets are collected simultaneously, providing a comprehensive view of the terrain. Now, we have to process the collected data using specialized software. For example, image can be stitched together to create detailed orthomosaic maps. LiDAR data can generate high resolution elevation models. Spectral data can be used for vegetation analysis and mineral identification. Now comes stage 4. Now comes the analysis part. Here we will analyze the processed data to identify lithology and geological features. This can be done through visual inspection of images, topographic analysis, and even machine learning techniques for automated classification. Now comes stage 5. Now we will integrate the results with Geographic Information System GIS for mapping and spatial analysis. GIS allows for creation of detailed maps that highlight geological features and their relationship. Stage 6. Final parts include developing a user-friendly reporting and visualization tool that allow geologists to interact with remote sensing data. This tool can display maps, images, and features information. Thank you.